In late October 2023, when Hamas launched over 700 missiles in a surprise attack against Israel, they hoped to cause maximum damage. But what they didn't know was that they were up against the latest iteration of Israel's legendary Iron Dome missile defense system, which intercepted more than 90% of incoming rockets. What makes this version of Iron Dome different from previous versions is that it uses AI to predict the trajectory of incoming missiles and automatically fire interceptors to take them down, all without any human input. But Israel isn't the only country working on this technology. The US, South Korea, and Germany are also developing next-gen missile defense systems that could rival Iron Dome 2.0. So in today's video, we're going to take a look at what these systems are and how they could change the future of warfare forever. But before we get into it, let's do a quick recap of how Iron Dome works. Iron Dome is an anti-missile system designed to intercept and destroy short-range missiles and rockets. It was developed by Israel Aerospace Industries and Rafael Advanced Defense Systems in collaboration with the Israel Defense Forces. When a threat is detected, a control center automatically activates the Iron Dome system, which then launches an interceptor missile to intercept the incoming projectile. The interceptor missile is equipped with a proximity fuse that detonates when it gets close to the target, destroying it in midair. This process happens very quickly, usually within seconds. Previous iterations of Iron Dome used radar to detect incoming missiles, but the latest version also uses AI to analyze the threat and make real-time decisions. This makes the system much more effective and efficient, as well as reducing the workload on human operators. According to Rafael, the developer of the system, the new Iron Dome can simultaneously engage with multiple targets, each traveling at a different speed and trajectory. This is a significant upgrade from the previous version, which could only engage one target at a time. In addition, the new Iron Dome has 4 times the range of the previous version, meaning that it can intercept missiles that travel up to 110 miles. Furthermore, it boasts improved accuracy and has been designed to deal with swarms of missiles. During a recent demonstration in June 2023, the system successfully intercepted 5 out of 6 missiles fired at a simulated nuclear reactor, highlighting its effectiveness and potential applications. But Israel isn't the only country working on advanced missile defense technology. The U.S. is also developing a next-generation air defense system called the Next Generation Interceptor Weapons System, or NGIS. Like Iron Dome, NGIS will use AI to improve its performance. According to the Congressional Budget Office, NGIS will leverage artificial intelligence and machine learning to enhance its ability to track and intercept airborne threats. Specifically, the system will use AI to automate many of the tasks currently performed by humans, such as identifying and prioritizing targets and making real-time decisions about how to intercept them. The benefits of using AI for these tasks are numerous. For example, AI can process vast amounts of data much faster than humans, which means that it can identify and prioritize targets more quickly and accurately. Additionally, AI can make decisions in real time without the need for human intervention, which can be crucial in fast-paced combat situations. The NGIS system is still in development, but it's expected to enter service in the early 2030s. Once operational, it will replace the U.S. Army's Patriot Air Defense System, which is the current workhorse of the nation's air defense network. The NGIS system will be deployed around the world, protecting U.S. troops and assets from a variety of airborne threats, including missiles, drones, and aircraft. The U.S. Army has already begun testing NGIS and has been impressed with the system's performance. In one test in July 2023, NGIS successfully intercepted a ballistic missile traveling at more than 5 times the speed of sound. This is a promising sign for the program and shows that it has the potential to be a major upgrade for the Army's air defense capabilities. Another country developing next-gen missile defense tech is South Korea. In response to North Korea's nuclear and missile tests, South Korea has been rapidly developing its own missile defense system called the Korean Air and Missile Defense, or KAMD. KAMD is designed to intercept and destroy North Korean missiles before they reach South Korean territory. According to the Korea Defense Acquisition Program Administration, KAMD will use artificial intelligence and other advanced technologies to improve its performance. One of the key features of KAMD is its ability to intercept hypersonic missiles, which are notoriously difficult to shoot down due to their speed and maneuverability. To address this challenge, South Korea has developed a new type of interceptor missile that uses a boost glide technology. This technology allows the missile to reach hypersonic speeds without having to spin or maneuver, making it harder for enemy defenses to track and intercept. In June 2023, South Korea successfully tested this new type of missile, bringing it closer to developing a complete hypersonic defense system. Another feature of KAMD is its use of multifunction fire control radars, which can track multiple targets at once and provide guidance to multiple interceptors. This is a significant improvement over previous South Korean radars, which could only track one target at a time. Overall, KAMD is a highly advanced and sophisticated missile defense system that could help protect South Korea from North Korean missile attacks. But perhaps even more fascinating than these systems designed to shoot down incoming missiles is the development of laser-based weapons that can do the same job. Lasers have long been considered a potential game-changer in the world of military technology, and for good reason. They offer several advantages over traditional missile defense systems. First and foremost, lasers are virtually instantaneous in terms of speed, meaning that there is no time lag between detection of a threat and the launch of a defensive measure. This could be critical in a situation where seconds matter most. Additionally, lasers are incredibly precise, meaning that they can target a specific missile without causing damage to the surrounding area. This level of precision could be especially useful in densely populated areas where civilian casualties would be a major concern. Moreover, lasers are potentially cost-effective compared to traditional missile defense systems, which can be very expensive to operate and maintain. Once a laser defense system is in place, it could theoretically run for the cost of electricity, making it a more sustainable solution in the long run. There are also no physical limitations to consider. Unlike interceptor missiles that have a limited range and must be launched from specific locations, lasers can be used to target missiles from virtually anywhere. This flexibility could allow for a more comprehensive and efficient defense system. However, despite these potential benefits, there are also some challenges associated with using lasers for missile defense. One of the main concerns is the high energy required to power a laser system capable of shooting down a missile. Currently, there is no practical way to generate the amount of energy needed to destroy a missile using a laser. Another concern is the potential for atmospheric conditions to affect laser performance. Things like cloud cover and humidity can interfere with the beam of a laser, potentially reducing its effectiveness. Finally, there is the issue of cost. While lasers may be cost-effective in the long run to operate, the initial investment to set up a laser defense system could be prohibitively expensive. Despite these challenges, research into laser-based missile defense systems continues around the world. Several countries, including the United States, China, and Russia, have reportedly invested heavily in this technology and have made significant progress. In recent years, there have been several demonstrations of laser weapons that could theoretically be used to shoot down missiles. For example, in February 2023, the U.S. Navy conducted a successful test of the Laser Weapon System 03, or LAWS-03, which is a high-energy laser weapon designed to shoot down drones and missiles. The test took place on board the USS Thomas Hudner, a guided missile destroyer, and involved shooting down 2 unmanned aerial vehicles, or UAVs, using a powerful laser beam. The laser weapon system used in the test was a solid-state laser that produced an energy-dense beam capable of destroying targets with great precision. This is a significant achievement for the Navy as it brings the military closer to having a reliable and effective defense against drone and missile threats. In conclusion, the future of missile defense looks incredibly promising, with several countries investing heavily in research and development and making significant strides in this field. From Israel's advanced Iron Dome 2.0 system to the USA's AI-powered NGIS and South Korea's innovative KAMD, there are some remarkable developments on the horizon. These advancements not only promise to revolutionize the way militaries defend against missile threats, but also offer hope for safer skies and greater security for nations around the world. One thing is certain: the role of artificial intelligence in modern warfare is only going to grow in the coming years. As AI becomes more advanced, we can expect to see more and more examples of its use in everything from missile defense to autonomous weapons. If you want to learn more about how AI is changing the face of warfare, be sure to check out our video on the 10 most lethal AI weapons that exist today. And if you enjoyed this video and want to see more content like this, please don't forget to leave us a like and subscribe so you never miss an upload. Thanks for watching, and we'll see you in the next one.